welcome to the RPS project. I'm Richard, and today I've got a little circuit for a dynamic microphone preamp. Basically, this thing. Now, I have to admit, it's not my own design. I got this off another YouTube channel. Now, I'm not sure what the channel was. I've searched for it again, tried to find it. If I find it, I'll put a link into it, and everybody else can have a look at that video as well then. But this is the circuit that the guy was building. Now, I've done it on RichCAD. He did it on some fancy software, but RichCAD, well, I think it looks great. Anyway, let's have a look at it. Now, he's got microphone over here. Let's just wave this at it. Microphone starting over here, and then we've got a transistor. There's 3 transistors in this, and it did state what they were, but it depends on what you've got in your transistor bin. I've used BC337s, and I think they're going to be just fine. This part of the circuit is up to this part here is basically the initial amplification stage, the first part of it, which is really, I think, is doing most of the amplification really. Now, this part of it, I'm not quite sure how it's working, because you've got your signal in here on the base of this transistor. Now, this is biased to be on, so we've got our current, so we're getting some drive on the output. But this one is only being affected at this point by the signal that's coming in. So I'm not totally sure how these 2 transistors are working and what their relationship is, but somehow they're helping to drive the output in a certain way, some way. I say this part is fairly sort of standard. He's not drawn it in a sort of typical normal way, so at first, when I first looked at it, I thought, what is it doing? So what I'm going to do is I'm going to redraw this section in a format that I understand. So I'll get into that now. And as you can see, I've now redrawn this section in a slightly different format, just so I can see it about it in a way that I'm used to seeing it, which is BC337 transistor I got there, basically biased resistor divider, but we've also got a capacitor on that base as well, collector resistor, collector resistor on the emitter, and the output is on the collector there. The only difference being is that the input is on the emitter. I've seen this circuit before. I've never really used it or tried using the transistor in that way, but I do know you can have your input on the emitter rather than on the base, and that's what we've got here. Microphone, capacitor on the emitter, base is biased, signal comes in and goes through to here. Now, I found that I didn't quite have all the parts that I wanted. Most of the capacitors I've got, I think really it's these 2 capacitors over here on the power, on the voltage input that I've maybe changed, and I didn't have a 47k pot. So what I've done is I've used a 100k pot and put 100 ohm resistor in parallel with that. And then over here we've got 3.3 meg resistor. Now, I didn't have a 3.3, so I've used 3 1 meg resistors in series, and that's what I've got. That's what I've put together. So let's go and have a look at that anyway. So here we have it on the breadboard. I've made it up on the breadboard, that circuit. Got it connected here. Here's my microphone, and it's that sort of old dodgy dynamic microphone, mono, that used to get cheap with stuff, but it's not a bad microphone really. It's yeah, nothing like all the posh expensive stuff, and I'm sure people will go in, you can't use that, it's rubbish. Well, this is all I've got to make it work, so this is my conclusion to making it work. So I've got the board now. I've tested it from this breadboard and it does seem to work. So really what I want to do is just push on to the next stage and make a circuit up. Got some strip boards, got a case, got a lid for it somewhere, fit a board in and the bits on the case, and fit it all into there with a battery. Going to use a 9-volt battery, so I don't have to worry about external power supplies or anything. And like with this thing, this is basically literally just an input, and it just comes off there. I split it onto the two connectors for the 3.5mm connector, which is tip ring earth, and that gives me my 2 channels out into my computer, rather than it just being a mono, which is a bit pants, which has always been the problem. I wanted to get this mono socket, get it in shot, this mono into 2 channels, not stereo necessarily, because stereo's more output, but yeah, that's what I've been needing to do, and this circuit does that for me. So I'm not going to bore you with all the making the PCB up and all that, and populating and soldering and all the time that'll take. I'll just skip forward to the part where I've made it and show you what I've got in the box. Okay, let's move on. Okay, I've made the board up, and I've also had to draw out the diagram of the circuit again, and I put on it my parts, what I'm using, a list of values, so I can make sure I get it all in the right place. You know, it's always good to do this as an exercise, just as, to make sure you get all the right parts and you've got all the bits you want. Then I had to basically work out how I'm going to put it on the strip board. So I made this bit of a sort of circuit diagram thing on there as to how it's all going to get laid out. Tracks are going to be cut and links where it's all going to sit, so I can follow that. Makes it a much quicker exercise than trying to do it ad hoc as you're going along, because then you end up with stuff that all over the place where you don't necessarily want it. A little drilling diagram for drilling the lid, so I can make sure I get all the bits in the place that I want it to be. So let's have a look at the item. That's just the case, that's the bottom bit. Actually, it's on here, and that's what I've got. I managed to create this little circuit, this nice long little circuit. It fits into the box, into the slots, because there's some grooves in here for locating the PCB, which is great, and this just slots in. The battery just sits at the front here. I've even put a bit of double-sided tape on there so I can stick it on there to make it stick in better without it rattling around. And that is the circuit. Nice and simple and very compact, really. Put it in quite a small box. Socket, first socket there. The other socket, the second one, the output is actually on the board. You can see that. And so it won't move about once it's in, because all I've got to do now is slot this into the grooves, get it in there. That just sits down nicely in there, and the lid just sits on top. As you can see, it's fairly well lined up. My drilling was a bit off, maybe. Never mind, I'm sure it won't make any difference. Well, let's put a cable in that. See, it goes in fine. Now the pot actually helps with the, I think it's sort of like, not so much a volume, even though it does work as a volume, but more as how sensitive the rest of the circuit is, so how much it can drive that second stage. And on-off switch. So let's put some screws in it. So let's try this out. Connector in there, connector in there, and let's plug this into the computer and see what happens, because that's what it's really going to be useful for doing like voiceovers, or where I need to do a screenshot of something and I need to have a microphone rather than using the camera microphone, because this camera here does have its own inbuilt microphone, which is great, but you can't change that. You know, you can't put an alternative voicing in there from another microphone, because you have to use that internal microphone from the camera. So let's see what the difference is between this, which would be just basically a pass-through, compared to this with a little preamp in it. So let's get and do that then. So here we have a couple of sounds that I recorded a little bit earlier. The top one being without the preamp, and the second one being with the preamp, and we'll have a listen and see how they sound. So let's do the top one first.
Hi there, this is the RPS project. I'm Richard, and today I'm going to have a look at microphones.
Sounded a bit dull, a bit flat. There is no mid-range in there. Very heavy sounding. And the second signal with the preamp.
Hi there, this is the RPS project. I'm Richard, and today I'm going to have a look at microphones.
Yep, that sounded a lot better. There's a lot more in there. You can see the difference between the two signals. It's a much better signal. Okay, it's not massive. It's not really boosting, you know, all the way up and down. I mean, I could manipulate this and make it a lot better, but it actually sounded quite nice, really. There's a little bit of, I think, hiss and noise in the background, but nothing to be worried about. And actually, this is a screen capture that I'm doing at the moment for these two signals, and I'm using the preamp mic, and it's sounding fairly good to me. So there you have it. Taking a cheap microphone with a mono input and turning it into a twin output on a 3.5mm jack that goes into any computer in the microphone or the line in. Brilliant. Which is much better than what I was doing. Well, basically I was doing that, but I was using this box, which is basically nothing more than a pass-through and wasn't giving any boost to the signal, whereas now this does give a boost to the signal. Makes it a bit more, well, I was going to say give it a bit more oomph, but just gives a bit more volume and makes it more usable, so you've got a better sound coming out of it, and that's exactly what I wanted. Taking this, which is a cheap microphone, mono input to a dual output with a bit of amplification. Now, for some people who don't have lots of money like myself, I have to use this type of equipment. That's all I've got. So doing this has been really helpful. I'll put a list of the materials used and any links in the comments. Hopefully I can find that video I originally saw it on. And that's it really. If you like this video, give me the thumbs up, subscribe, and all comments are welcome. See you next time.